Hi, this template is a unit plan overview template that can be used for project-based learning and contains the same elements that the Bucks Institute model for project-based learning utilizes. However, just like the Bucks Learning Institute says that project-based learning can take various formats as long as they all contain the 8 essential elements of PBL cited in the article, but that each of these formats varies slightly in their format or their scope. So given that a problem-based learning PBL is contextualized around a real-world problem, and real-world problems are solved by using the design process to create a solution, the template takes the assessment portion of a traditional UBD-styled unit plan, and rather than citing the assessments over at the top of the unit plan and just saying if they're formative or if they're summative, what this template does is it places the assessments right into the sequence of the days or the lessons down the left-hand column here, and basically aligns up what it is the teacher is doing at each step of the design process, as well as what the student would be doing at that corresponding step of the design process. Now, since this pragmatic or logical approach to problem solving following a design process creates an opportunity for students to be doing something at every step, what those students are doing will likely correspond or correlate to a specific standard that you were trying to have students achieve. Now, every single step of the design process for your chosen PBL, problem-based learning experience, it's not that every single step will definitely correlate to a standard, but you will be able to bundle multiple standards into this problem-based learning experience because every standard now, particularly from math, language arts, and science, and now the design thinking standards, are all statements about what students will be able to do as they engage in a specific practice. So that practice ties to terms like identify a problem, ask a question, provide evidence, analyze and interpret data, etc. So any step of the design process is a natural opportunity for a specific practice, and you'll be looking to find where these practices that your kids engage in correlate to standards. So when you put that standard in this column, in the standards column, the standards may repeat. For example, if I have a hypothesis for how I think my chosen solution is going to work, I may be creating an argument from evidence I got back up here in the research step, for how I think my selected solution is going to function or work to solve the problem or meet the requirements that might be created in a design brief up here at the ask or identify problem step. Now, I may not totally achieve that standard in my hypothesis, but after I test the solution and I see how my solution did perform or how it stands up against the other solutions in class, I'm going to get back data and I'm going to form new understandings. And there's a better chance now that I might be able to fully achieve a standard later on when I present my redesign. So redesign doesn't have to mean that you completely do the design challenge over again. It just means that you're taking what you learned from testing and presenting your solution and any data you get back from that, and using that in a new evidence-based argument to support how you would have changed your solution or any aspects of your solution so that it did a better job in addressing the requirements in the design brief. Now, every time you have students engaging in at any step of the design process, no matter where you're at, you're going to capture them engaging in that step in some documentation. So as opposed to having separate worksheets or separate handouts or packets that happen throughout the scope of any unit, imagine that all of those handouts and packets and everything are all tied together in one single document you could call an engineering notebook. So imagine that your engineering notebook is something that would naturally subsume a scientific journal, or would naturally subsume anything that you would have students doing throughout the scope of a PBL. And when you capture them doing that thing you want them to do, whatever you're capturing, whether it's done through a writing prompt or a morph chart like we did the other day, where we designed different, brainstorm different ideas for a bar of soap. We captured them in a chart. Or if there's a writing prompt, or if students are drawing a picture of something, or if they're describing something, whatever it is, that stuff gets captured on these individual pages that are organized by the steps of the design process. That's the engineering notebook. And whatever you have students putting into an engineering notebook, if it does line, if it is serving the purpose of meeting a standard, we can measure that standard, or how well the student is, how far along they are achieving that standard, by then linking that to the evidence statement that goes with the standard. Now, if you do NGSS, you know where you know that the standards all have evidence statements that can be found through the NGSS website. But now the New Jersey state learning standards also have corresponding evidence statements that clearly lay out what does it look like when a student engages in a specific standard and produces whatever they produce can be used as evidence to show that they're meeting that standard. So by using this natural design process that people use to solve problems, and yes, real engineers professionally, they solve problems for a living, but they still use the same process. And this process is still the same thing that a regular person like you and I would follow if we're going to solve create a solution to a real world problem. And those solutions take the form of a technology, right? So you can see here in this template, there are two different versions of the design process. In elementary, we try to adopt a common language of design process steps, usually maybe a 5-step model, because kids have 5 fingers. And those steps become more complex or broken out as students get older and encounter a 10-step design process here. Now, just because there's an equally distributed number of rows here, and they're all about the same size for each one of these steps, it does not mean that the design process is always something that happens with the same amount of time at each step, depending on how you adapt your unit, or where you feel you need to spend more time on something. Certain steps that you have here could be 2x, 3x, 4x, 5x as long in terms of their instructional time they use in the classroom as any other step. So definitely look at this template as something that it can expand, maybe much more complex in one area than in another. You need to consider this research step here as the catch-all term for inquiry or discovery, or any of the things that you either want to lead students through yourself or send them out to investigate independently. But this is all the things that they need to learn and understand if they're going to be able to eventually develop a solution, pick the best one, and make it in such a way that it's able to meet the requirements that are set out in the design brief. So in future videos, I'm going to go into more detail and provide more explanation for different pieces of this template. and how they relate to best practices for problem-based learning. And hopefully you can use this template as a way to organize your thoughts and ideas and begin to put the pieces together for what could become a pilot for your first unit of PBL. Again, this is one version of project-based learning called problem-based learning. And in my opinion, in Rutgers' opinion, I think the academic opinion in general, as we see from the notes document, that all of these are acceptable forms of PBL, and the best practices that I'm making recommendations for treat PBL as problem-based learning. And this is what you find that comes out of, yes, the STEM and the STEAM world, because those things have natural high-level connections to technology and engineering, but also the humanities and the arts and every other content area can still use this process and support this process with design thinking and a series of lessons that introduce students to design thinking, so that when they get into a problem-based unit like this, they'll have the skills they need to step up to the plate at each portion where they're asked to do something. All right, more elaboration on this later. Thank you so much for your time, and I'll see you in the next video.